All right, welcome everybody. If you haven't heard of Revit and you don't want it to work faster for you, then you might be in the wrong place. Otherwise, you are in the right place. There's the class summary, learning objectives that you saw online, so we're not going to go over them. We're going to go ahead and get started with the expectations for this class, what you can expect, what I can expect, and an introduction of myself. If you have questions that are going to take us off subject, let's go ahead and keep those questions to the end. We'll save some time at the end for those questions. If you've got questions that are on topic, you want clarification of something you see on the screen, those questions are welcome anytime. Feel free to raise your hand and we'll try to answer those as they come up. The experience level for this course is all levels from beginning to advanced. Now, there's going to be different sections where we talk about really wrapping our head around this concept of the API, trying to get started on our first project, and then we're also going to go to the other end of the spectrum where we're going to actually see some very specific code. We're going to get into that nitty-gritty stuff called code and figure out how to do very specific tasks. Just on that subject, how many of you guys are more towards the beginner end of that spectrum? Looks like most of us. So there's quite a few. Now, on the advanced end, who of you guys are advanced? Okay, so we've got a few of you guys. So the goal of previous classes that I've taught has always been to motivate, to inspire people, give people ideas of what to create. But those are great things to show the power of the possible and all that things. But really the focus of this class is a little bit different, and I hope you see that. And the focus of this class is not only to give you those ideas to motivate you to get started, but also to enable you, to actually give you the resources where instead of just saying, wow, that was neat, now I've got to go back to my regular job and do my regular work, I want you to say, wow, I'm going to go home and start using this work today. So with that, we'll start with a warning. The following content was prepared by an engineer, not a programmer. The samples of code shown may contain disturbing examples of poor programming and represent only one of many ways to accomplish the desired objective. So as I said, I am an engineer. That just means that when people say it can't be done, we either find a way or we make a way. We just make it work. Since last year, you could also say that I'm a software developer. After some overwhelming response I got from my AU class last year, I decided to give away all of my tools for free. Turned out people actually didn't want them for free. They wanted to pay for them. So who am I to argue with them? So I went ahead and started distributing them and put up a website. So there is a website where you can get these tools that are going to be discussed. Now, the tools are not the focus of this. I want you guys to create the tools. I want you guys to be enabled to take this home and start making Revit work for you. So people always ask me, how did you get started? What is your programming experience? So in college, they make you, as an engineer, they make you take a few undergraduate courses on programming. And they're hard, they're boring, and at that time you say, I never want to do this ever again in my life. And then I got started doing engineering calculations, design, and I would see these things, and I kept saying to myself, there's got to be a better way to do this. Why are we doing the same thing over and over again? Or how come these things are so repetitive? And then I started writing a few lines of code. It was VBA in Excel. It was VBA in Microsoft Access, doing databases, really managing all this data, being able to reuse it, make it work for me instead of having to do the same thing over and over again. And that's just me trying to get out of work. That's trying to make my life easier. And so I've broken this out into 5 different sections. The first 2 sections are really for most of us, the beginners here. And I hope that the advanced people aren't going to get too bored. I think there's some things you can take from this as well. But this is wrapping our head around what is this API, what does that all mean, and then the process. How do I go from wanting to create something to actually creating something? And then in the middle section there, we're actually going to step over into Revit and show you actually how to get started, actually creating a macro. We'll do that live. Now, this is always something scary for a presenter to do live programming. Something can always go wrong. Of course, it's not going to. We're not going to jinx ourselves here. But then the last 2 sections, we're going to look at some very specific tasks, some specific tools, to give you some ideas of what can be done, what has been done, and to give you some specific lines of code to show you the key lines of code that are actually doing a lot of the work. So understanding the API and its potential. And where we need to start with this is, what is an API? Okay, when I started, I was pretty ignorant. API, I know somebody says, hey, it's the application programming interface. Okay, forgive me, but I have no clue what that means. So interface, is that a new software that I have to install? I have to learn some new interface that gives me like secret access into Revit? Or, what is that? Is it, do I have to learn a new programming language, a new scripting language? Do I get to look at the source code of what those Autodesk people did in there and I get to manipulate it so it works for me? I mean, what exactly is this? So it turns out that it's really just a list of functions. A list of functions that you can tell Revit what you want, and it returns something back. Now that list of functions is stored in a couple DLLs that can be found in the Revit folder. And so the DLLs have a list of all the functions and classes that you can say, hey, I want something, give me something back. So I think about this kind of like Revit's like a restaurant's kitchen. In this case, let's pretend that it's a kitchen that produces sandwiches. And so all the people that are using the regular Revit interface, they're walking up to the little glass box and they're getting their little prepackaged sandwiches. So they're walking through the line and they say, okay, I'm picking up a sandwich. Okay, it's tofu again. So what they don't know is that you can actually, if you sit down and you actually pick up the menu, you can actually order things from that. You can choose what kind of bread you want, what kind of meat you want. Hey, I want some special toppings on here. So what the API is that menu. You actually get a list of, hey, I want to have this on the side. Hey, I want to order this, or I want to do it a little bit differently. And once you've had those sandwiches that you order custom, those little prepackaged tofu sandwiches just don't seem so appealing anymore. And so that's exactly what we're talking about when we want to use the API to drive Revit. Now, just like a restaurant, you also don't get access to the kitchen. You don't get to see the ingredients that they're putting together, how they're preparing it. You just make some commands, tell them what you want on the side, and then the waiter brings back your order and it gives you the results. And so I said that the API is contained in some DLL files. So then my second ignorant question that I asked myself was, what is a DLL file? I mean, to me, a DLL file was the reason why my computer kept crashing. I kept getting those little warnings. I knew that when I decided to delete them because I was sick of the crashes, guess what? Things stopped working. Okay, so that's not a good idea to delete the DLL file. So what exactly is in those mystical things? So it turns out it's just compiled code. It's code that somebody's written into functions or classes, and then it can also contain some resources. Those resources might be icons that it uses, images or files that are stored in this thing. So essentially it's the same thing as an exe file. I assume that most of you are familiar with an exe file. You double click on it, it starts up a form, it starts up an application, it does something for you. Now the DLL is just like that, except for it doesn't have a set starting point. It doesn't know right when I double click this is where I want to start. It actually has multiple functions, or it's got different things in there. It has to be told where to start. And so we create DLL files that then we tell Revit, or we ask Revit, okay, I want you to call my DLL file, and this is where I want you to start. But also when we're creating programs, we reference other DLL files, and we then have access to those menus, those list of commands, and we tell them what we want to start. So I keep coming back to this analogy where the DLL is kind of like a restaurant in its menu. And I do that because in your own project, as I mentioned, the first thing we have to do is we actually have to load the menu to Revit, or what are the commands that we want to have access to. So we load the Revit API DLL and the Revit API UI.dll. And we'll talk just a little bit more about that later. But then you also, let's say you want to know, I want to access Excel. I want to start writing to worksheets and cells. If I say, hey, I have a new worksheet, I want you to put this in a cell, your program isn't going to know what you're talking about. You actually first have to say, hey, I'm going to reference this other DLL. I'm going to reference the menu so I know what I can order from the menu. And then once you do that, as you're typing in the code, it actually auto-complete for you and give you a list of all the functions. So the .NET framework. What is the .NET framework? Just really quickly, it's just part of the Windows API. This is where if you want to go to the have a file open dialog, you don't have to design how to traverse the file system. You don't have to design where the OK button is, where the little Explorer windows are. All that's pre-programmed. You just say, hey, Windows, I want a file open dialog, and it knows that stuff. So it's a prepackaged functions that you can call. So the big question, what is it that I have access to manipulate in Revit? Now there's a whole bunch of things. I'm just going to list a couple and then tell you where else you can look. But here on the list, you have access to parameter data. You have access to properties. You have access to create things, elements, schedules, families, parameters. You can monitor changes and activities that are happening in Revit. You can also react to events and dialogues. If something pops up, I want to do something else. So you can do all this stuff. Now, beyond that, if you want to learn about a little bit more what else is available, there is a Revit software development kit. That's what SDK stands for. The software development kit is not necessary. You don't actually need that to start coding anything. But what it does give you is it gives you a help file, lots of instructions. You can search things. You can kind of figure out how to do your first project. It also has lots and lots of code examples. So if you'll have examples on how to filter, how to create parameters, how to create family geometry. It has a lot of examples that will be very helpful for you in starting your own project. Now in there also, there is a tool called Revit Lookup that you can install into your ribbon in the Add-ins tab. What that does is it allows you to click on any element, or you can look at your project as well, and it gives you a list of a lot of the properties, the parameters. You can see a lot of the data that Revit knows about what you just clicked on or your project. And what it does is it gives you kind of a good understanding of what it is you can access, what it is that you can change, and how you can get that data out to somewhere else. I just wanted to mention one thing is that sometimes when you use that tool, and the screenshot is in the bottom left, you'll click on either a parameter or a property and it'll say it's read-only. You're like, darn it, I wanted to change that. Well, read-only doesn't mean you can't change it. For example, let's say it's the location of an element. It'll say, hey, it's location and it's read-only. You cannot change that location. It just means you cannot say, okay, now I want its location to be this X, Y, and Z. But there is a move command. All you have to do is say move, and then you can have start and end or whatever the inputs are for the move command. I just want you to be aware that just because it says read-only doesn't mean you can't change it. And just because there isn't a command built in doesn't mean that you can't find a different way to go around it. So there's always, not always, but there's often a workaround where you can get things to do what you want. And then in Microsoft Visual Studio, which is a development environment that we'll go into a little bit more, there's an object browser. And what the object browser is, it can read the menu for you. You can actually tell it either a DLL or your project or whatever else, and it'll give you a list of all the classes and functions in there. So if I'm curious about work sets, I can type in work set, and it'll show me all of the class names and the functions that say work set in there. Here I've typed in create here, and I'm searching for anything that has to do with create, and it'll give me a list of all of these functions that have the name create in there. So it's something where you can search. Not only does it tell you what the path is to call that function, but it also tells you what it's expecting in inputs. And if you look there, it says the parameters, what it's expecting. It's expecting a document, a curve, wall type ID. It gives you an explanation of what you need to pass it in order to get your result back successfully. So which programming language should I use? The answer is it really doesn't matter. Now, in the past, it's just been the .NET languages of C# and VB.NET. In 2014, they added Ruby and Python. I want you to know that even in the Sharp develop that ships with Revit, the programming editor, you can actually switch in between any of these all the time. You can just say, hey, I want to convert all this from C# to Ruby, from VB.NET to Python. You just click a button and it converts it. So not only does it not matter what language you're typing in, but if you want to change it later, you can. And the point is this first part here is that you have access to the same kitchen. It's the same menu. It's the same exact functions, no matter how you're calling it. Now, C# and VB.NET are almost identical in the way that they're structured. Ruby and Python are a little bit less structured. And I don't program in Ruby and Python, at least not yet. Maybe someday I will. They seem to be, from what I've seen, a little less structured, which actually makes them super flexible. They're kind of interesting to look at. But they're also, the cost is that you don't have some of the built-in automatic checks. You don't have some of the built-in autocompletes, especially in Microsoft Visual Studio. So if you're asking the question, which language do I start with, you probably want to start with one of these top two, C# and VB.NET. So on to the process and resources. This is how do I get actually started. Let's go ahead and get started and get ready to get right into the macros. So when you first decide that I'm going to create an add-in for Revit, you have three main options of what kind of add-in I'm going to create. There's a macro. This is basically, you don't need any external software. You don't need Visual Studio. You don't need anything. You can do this right in Revit. And it's something that it's a command that you manually start, and it manually stops it when it's finished. And it's stored in the project or on a single computer. That's important because it's a little bit harder to share with others. Now, the next two are external. Basically, that external part means that it's stored in a DLL file. You compile it, and then you can share it with your colleagues. You can share it with somebody else. There's external command. This, again, command meaning that you call it, it does whatever it's supposed to do, it stops, and it's finished. An example would be if you click on a button and you want it to actually perform a function. Maybe you select a region in Revit and you want it to automatically compute a 3D section box. When it's done, it stops, it's out of memory. All things are good. The difference between that and an external application is that the external application actually starts with Revit and it stops with Revit. It's running all the time. And so this is useful if you want, for example, if you want your own custom ribbon in the interface, or maybe you want to be constantly monitoring for something. Those type of things would be an application. They would be starting up with Revit, and then they're not finished, essentially, until Revit closes. So we need to, if you're doing anything external, you need to let Revit know where it is and how to start it. So if we look at the diagram here on the bottom, when Revit starts, it's going to look for some files, and one of the files that it would look for is a .add-in file. A .add-in file, and you can get some information in the SDK, it's just a small text file. It's only got a few lines of information in there in the text. It tells it where's the DLL, what is the path to the DLL that I'm going to load, and which function, remember we have to tell it where to start in there, which function am I going to start in that DLL. So when Revit's starting up, as long as there's an add-in file somewhere in one of the standard folders, then it's going to start that application with Revit. And then that application, in the event that it's like a ribbon, it's essentially going to just sit there and it's waiting for user input, or it's waiting to catch an event, or whatever it is. The command is the bottom line here. When the button is clicked, that button will then tell Revit the path to a function inside of a DLL. So that could be the same exact DLL. Your function could be inside the DLL of your application. It could be in an external DLL. You could be having it call another DLL that you created, that somebody else created. But the thing is that you tell it to start, and it won't start until you tell it to. So getting started. Now that we've decided we're going to get started, the first things I would do is I would install Visual Studio. If you're doing macros, this isn't even required. But if you're going to compile anything to a DLL, I would highly recommend getting Visual Studio. The Express versions are free, and you can program anything in the Express versions. There are some tools and things that you won't have that are in the professional version, but as far as access to the API, it's all the same. You're going to have all the same power with the Express versions. And then download the Revit SDK. As mentioned before, it's not required. It's not going to give you a leg up, other than it gives you a whole lot of examples and information that's going to be useful, especially as we're starting out. So understanding Visual Studio. Revit ships with Sharp Develop, which is, I think, an open source kind of copy of Visual Studio. And a lot of this stuff is essentially the same. I mentioned before that you have to know the path to the function that you're calling. And so in programming, a lot of times that path is created or composed of a namespace, a class name, and a function name. And so, for example, if I want to display a message box, I need to know that that message box comes from maybe it's system.windows.forms.messagebox.show. So every time I want to display a message box that says something, I have to type in system.windows.forms.messagebox.show, and it will show that message box. So on to the second point here is instead of having to type that out every single time, you can create shortcuts at the top of your code. When you first start looking at these example codes, you'll notice at the top, and I'm looking at the top screenshot here, at the top of most of the code you're going to have, and that's C#, but if it's VB.NET, it would be imports. but you're importing these shortcuts. And basically what that means is that every time I say messagebox.show, it knows to look in those locations first. And if it can't find it in those locations, then give you an error. The important thing I want to mention on that is that when you go to online, you're going to blogs, you're going to different places, a lot of times you'll get sample code. And the sample code a lot of times won't include the stuff at the top. They just kind of assume that you know what you're doing, and they're going to say they're going to have messagebox.show, they're going to have declare this as a Revit document or a Revit family. But you paste that into your code, and all of a sudden you've got all these little red squiggly marks saying that, hey, I have no clue what you're talking about. What is a family? And so you have to be aware. And if you're programming, there are some shortcuts. You can either look in the object browsers we showed before to see what that path is, and you can add that path to the top, or you can type out the full path, or you can hit control dot, control period in some of the development environments will show you what it thinks it might be linked to. And I put one example here, autodesk.revit.db.view. It turns out, depending on what you've got loaded at the top, if you type in a view, it might actually give you an error that says, hey, this is ambiguous. I don't know what you're talking about. It turns out that under, I don't know if it's Windows Forms or one of the other things, there's also a view. But it means something completely different than a Revit view. And if you come up with that, you may be forced to actually type out the full path, even though you have the right shortcut up at the top. And then references. To add a reference to your project, you just, on the right-hand side, or actually it depends on which environment you're in, how you've set up your views, but in your Solutions Explorer, you just right-click on References and you hit Add Reference, and it'll give you a list of all the standard Windows references. It'll give you a list of Excel and a whole bunch of other stuff if you want those. For the Revit reference, you're going to have to go to the Revit program folder and find Revit API.dll and Revit API UI. And these are very well documented in the SDK, so you can go there. But again, what that does is it gives you access to all of those classes, all of those functions that you didn't have access to before you reference those. And then real quick, resources. We're not going to spend time on this, but just so you know, you can actually embed files. Sometimes it's icons, sometimes it's images, sometimes it's a file that you want to export. Maybe it's a text file, Excel file that you want preset. You can actually embed those kind of like a zip file with your DLL. And so you can have access to those during your program's runtime. And then the locals window, this is important just to know that when you're debugging, so if you say, hey, I just created all this code, I run it, I either get errors, maybe the information isn't getting set the way that I want. When you hit debug and you're stepping through it line by line, you can look and see exactly which variables are being set, what they're being set to, so you can do it by function, do it by line, and you can see exactly what changed, when it changed. You're like, oh, I didn't realize I was resetting that variable then. No wonder why it's not giving the correct information to the next function or whatever. Just be aware that's there, because when you hit debug and you're going through it, most of the time by default it's not shown. Some people, there's many ways to debug. You can use console.writeline. You can send things out to a text file. You can use message boxes if you want to figure out what's going on. I just want you to be aware that when you're doing that there is a place where all that information is stored. You can see what's stored in your arrays, in your strings, all this stuff. Usually the first thing that I want to do when I create a program is, I'm not really into the command line or just seeing text and stuff. I want to see a form. I want to start putting buttons somewhere. I want to put text boxes. So the very first thing that I want to do is I want to create a form. Creating a form in any of these environments is very easy. You can just right-click, add new item, I add a form. Then you have this form that shows up with these buttons, and it won't do anything. It doesn't know what Revit is. It can't access your parameters, and you don't know what's going on. I got all these pretty buttons and text files, but I want to actually interface with my Revit document. So it turns out you have to pass your form information. You have to actually say, I want a new form, but I want to give you access to this Revit data that I just got. And this is more important when you're creating external applications or DLLs than it is in the macros. In the macros, you have a little bit more direct access to the Revit stuff. So I've included some code here. And by the way, all the code that you're going to see is all online. These slides are online, and as well, there's also a handout that has all the same code. It has all the code that we're going to be using for the macro. All that stuff is online, so don't worry about missing it. I see a lot of people taking pictures, and you can continue to do that. But all of this stuff is online now, and there's additional material besides this in the handout. So to send your data to a form, you have to put, hey, I want a new form, and then in parentheses, and this is standard programming, you put in parentheses what you want to pass to that form. And so in this case, I put my Revit data, I made up that name, but when you have an application, Revit is going to send your application the Revit database, essentially, all the parameters, the elements, and I want to send that to my form so that then I can use the form to manipulate it. When you do that, if you just type that in and you say, here's my Revit data form, your form is going to say, I don't know what Revit data is. I'm not actually expecting you to send me anything. I was just going to run on my own. You have to remember in your form to create an alternate new function. And in that new function, you would put what you're expecting as an input. And so in here, I'm looking at the second line here. I've got a new. I'm going to expect some internal. External command data is the type that Revit creates. That's just what they've called it, their database that they send. And then what I've done here is I've just set a variable that I've actually put outside of my function that's in the class. What that means is it's going to be available to all the functions, not just this one function. And so essentially you could think of it as sort of a global variable. And I'm setting that variable to the incoming Revit data. And so then I'll have access to it in any of the functions that I do from there on out. And we will actually see that in the live macro demonstrations. So before I get to the live macro demonstrations, I want to show you a video. And this video is a video that I produced to demonstrate and also to promote some tools that I've put on my website. But what I want you to be looking at here is actually what it is that we're trying to accomplish. What is the end result? When we start looking at some of this nitty-gritty code, it can get pretty boring pretty quick, and you just see some text or some values being set. But I want you to get a picture of what this can look like when it's all said and done.
RushForth Projects has made available a number of tools that increase the efficiency of all Revit users in the AEC industry. These tools help contractors leverage the model database by importing or exporting Revit element data using Microsoft Excel that can be used with external databases or COBie worksheets. Architects can use advanced filters to find all doors in a model that are greater than 3 feet wide, then change their material properties to steel and their height to 8 feet. Mechanical designers may export all space airflow calculations for use in external calculation applications, then have the ability to import the results back using Excel. Electrical designers have access to tools that automate moving or merging devices onto circuits or changing the electrical panel for a group of circuits. They may also make use of ray trace tools that place elements around the perimeter of selected spaces at desired intervals. Energy analysts may find it useful to copy architectural room properties to spaces or automatically create windows with properties for energy analysis, using the architectural windows or curtain panels for determining locations and sizes. Production specialists can purge categories out of a model or automatically create hundreds of views and sheets in minutes instead of days, with the ability to automatically place views on sheets and have project-wide control over the alignment of the viewports. A project coordinator may need to find and replace text in parameter values or quickly view a specific area on a floor plan in 3D in order to verify clearances, element placement, or other model information. A BIM manager can automate quality checks such as setting the scope box, view template, visual style, and detail level of all published views. No matter what your role or discipline, these are time-saving tools that no Revit user should have to work without. Visit the website to find out more about how these and other tools can save you time by automating your workflows. RushForth Projects, where innovation creates solutions.
So that's what my voice sounds like in the morning. So we're going to jump into the code, and as we do that, I'll start with this warning. Programming code is known to be an addictive substance. Possible side effects include loss of sleep, loss of appetite, and yes, even loss of friends. So what are we waiting for? Let's get started. So I'm going to exit the presentation here, and let's jump right into Revit. Making sure it shows up. All right, I'm going to sit down. If for some reason something shows up on the screen funny that I'm not looking at, of course you can't see what I'm looking at, holler at me because I can't see the screen very well from here. So this is just the sample Revit project. What I want you to see is how easy it is to start your own project, to get started with the macros and start pasting in some of that example code that you're finding. So in Revit, I just opened up a new session. In the Manage tab, there's this macro manager. When you open up the macro manager, I'm going to go ahead and hit New Module. This is going to be called David's Module. And you choose which language you want to start out in. I'm just going to choose VB.NET. Hit OK. So this first screen that you're looking at actually has two options. Those two tabs, one of them actually is the name of the project that I'm in, the RAC underscore whatever. The other tab is the application. That actually stores the app on your computer. That means it's going to be available for anything that you open. Anything that you open, you're going to have access to it. When you store it in the project itself, two things will happen. One, it'll actually, anybody else who's using that project, if you're on a work-shared project, they'll have access to it. They'll have access to the source code. They'll have access to everything, which may be what you want, maybe not what you want. The other thing is that you'll also, some of those users will start getting warnings that, hey, there's macros enabled in this project. Are you sure that you trust this? Do you want it to be able to run? So sometimes those macros, those warnings can be annoying. So just be aware that if you're doing it in the project, those are some of the side effects. So I've created a new module, and the first thing that it does is it gives me some starting code. And my first instinct is just to start pasting stuff in here, which would be the wrong instinct, because what happens is if I go back into Revit, if I click on this module, I can't run it. When I compile it, it'll run some of the stuff in the startup, but I actually have to create a macro. So the second step, and we're just going to call this David's macro, and hit OK. And the only thing that does is actually it only adds 2 lines of code to start a new routine. So now that I've got here, what is a module? The question is, what is a module? And the answer is, I don't know. If you're in Visual Studio, you have solutions, you have projects, and in a solution you can have multiple projects, and in the project you can have multiple functions. And so the macros are actually functions. The module would be sort of a project. It's where you can have multiple functions, and they're all stored under one module. So it's just a storage ability for you to kind of organize how you're doing these things. So you can export them separately as projects or save them. And these are all saved on your C drive, on your hard drive. So we wanted to do something, and as I said before, usually the first thing I want to do is I want to show a form. So I'm going to show you real quickly that we're going to come over here, and in this one, this is Sharp Develop, which comes with Revit. This stuff is on the left. Usually the Solutions Explorer is on the right-hand side in Visual Studio. But I'm just going to right-click on my project or my module. I'm going to add a new item. And there's some different options here, but I just want a form. And we're just going to call this David's form, because we're creative. So it's created a form. Now in Visual Studio, it's actually going to default to the design. When you first create it, you're going to see this. In this, it went straight to the code. Now the form actually has the layout, and it also has the code. In the layout, I can go to my tools, which are here on the left, and I can say, I want a button. So now I have a form with a button. Now, right now, if I run my program, I'm not going to see this form. I actually have to tell it that I want to have a new form and I want to show it. So if we go back, let's go back to our application here. So whenever I run my macro, whatever I just did, I want to, in VB.NET, dim is to declare a variable. So I'm going to declare form to show as new. And notice as I'm typing it, actually, it'll give me options of what's appropriate there. So this is as a new David's form. So I don't have to type in everything. It actually auto-completes for me. And then I can say form to show dot show. And there's show dialog and show. And real quick, the difference between, so I'm going to explain these two lines of code because they are important to understand. First of all, I'm declaring a form to show as a new David's form. Now, this was actually a little bit confusing to me at first because I was like, well, I just created the form. I don't need a new one. It already exists, right? But the David's form is sort of like a class. It's an entity, and I can say, well, you could actually potentially have multiple of them. You could actually have multiple David's form. I don't want of this, but just as a generalization, you might want multiple of a certain type of class. So I'm declaring a new one. And so I'm saying, okay, now this form to show actually is of that type David's form. It actually belongs to that family. That's what it is. And then the dot show dialog or dot show is just a built-in function to actually call it and make it appear. Now the show, if you do dot show, what it is it actually, it's non-modal, or modeless, I should say. What that means is Revit's not going to stop and wait for it to complete. It runs parallel. If I do dot show dialog, what that means is that I can't click on Revit until I've finished whatever it was trying to complete. I either have to answer the questions and hit OK. That form needs to complete before Revit is going to continue with the next command. And so it's important to understand that because some things you want to do in parallel, and other things you need to know the inputs before you pass them on to something else. And so if you're doing transactions where you're actually setting Revit data, their parameters, it needs to be show dialog because everything is very linear. You can't sort of do things in parallel while you're doing other things in the Revit interface. And so that's the difference between show and show dialog. Now, if I'm not forgetting anything, which you can raise your hand and feel free to correct me if I am, I should be able to just build this and run it. Oops. If I can get this touchpad to work. Build solution. Down here on the bottom left, it tells you that it's built successfully. What that means is now I can hit run, and the only thing that we've done is made a form show. So I've got a form with a button. Now I click the button and nothing's going to happen because I haven't told it to do anything. But that's usually the very first thing I want to do. And so I just want to make sure that you understand how simple it is. It's only a couple lines of code. We get that working. Now, as I mentioned before, this form, especially if it's an external application, isn't going to know anything about my Revit database. Now, I originally was going to type all this stuff live for you. It turns out I bored even myself doing that, so I don't want to bore you with typing in front of you. So I actually have one that I already typed up. And as I mentioned before, all of this code is in the handout. Let's go back to the macro manager. And I've got this AU module. And what I want to do is I want to walk you through really quickly what it does, and then step through the code so you can kind of see exactly how you can take this home and how you can start manipulating that code to actually do it, make it do what you want it to do. And here it's loading up. Taking longer than I thought it would. While it's loading, anybody have one question? Got time for one question while it's loading? Is the API different for the different versions of Revit? Yes and no. There are a lot of the API. Basically, if you're going to run a program on Revit 2014, you have to reference the Revit 2014 API. Now, if you've compiled something in the Revit 2013 API and it doesn't use any new functions, there is a possibility that it will actually continue to run with the same compilation in 2014, but I wouldn't recommend it. So essentially, you need to reference the latest API DLLs, make sure that you've got the latest revision of the functions and classes, because as it's running, it'll actually, whenever it's calling an API function, it's going to be calling it from that version's DLL. So if you call something incorrectly, you're going to crash your program. All right, so it's up here now, and this is the same thing. What I've done is I have, instead of just doing the .show dialog, before that, in my new, I've passed it this my UI doc. And so this my UI doc, and that's just a name I made up, but it's a user interface document. And in the macro, you can just say me dot, or if it's C#, it'd be like this dot, and then you'd have access to active UI document. That's your active document. If it's an external command, you're going to be able to pull that from the Revit data that it sends to your command. But essentially, you're going to want to have access to your document. And so I'm now passing this over to my form, which let's look at the form code. In fact, let me show you the main sections of code, then let me run this for you. So your form already has a new. This is what was built in there, and I created a second new with a different input. And yes, it's okay to have more than one function with the same name, as long as the inputs are different. If I'm back in my application, and if I said this as a new AU form, I'm going to. So if I start with an open parentheses there, it actually tells me I've got one of two available options. One of them is the new with no input, and the second one is a new with a UI doc as the input. And so it actually gives you a lot of help as you're going through that. So it's okay to have two new functions, even though they're the same name, they have two different forms. Two different inputs here. Nope, it's not what I wanted. See if I can figure out how to put this back. There we go. All right, so then I've got my new. The next thing I have is my button click. What this is going to do is I've set this up. This is similar to the parameter transformer, if you guys are familiar with that tool, where you're able to take properties and you're able to either export those. This one's going to export to a text file. You can also have it run filters. So this is going to have some basic exercises in how to filter, how to export to a text file, how to access some of the properties. We're going to step through this in just a minute, but let me just highlight this so you see how big it is. It's really not that long. A minute, so it's that long. So there's the end. So it's essentially really short. Let me show you the sections in here, and then let me run it. And I'm on this touchpad, which is not agreeing with me completely. So this first section here, notice this is dim, dim, dim. I'm just declaring variables. These are the variables and what I'm expecting to put into those variables. This right here, this is the selection input that you have. And this is where you have control over the code that's already been written. I want you to be able to not only change this code of what the inputs are, but I want you to then go through and understand, and you can, on your own time, step through all of those things and start playing with moving things around, changing some of the statements, and getting them to work just the way that you want. But I can use my selection without a filter. So basically, if I select elements in Revit and I set this to true, then it's going to use whatever elements I've selected. The next one, if I set this one to true, selected items only, this is if I'm going to filter, say I'm going to filter for walls or for something else, it's only going to filter my selected items. Or I can change that to current view only. If I set the first one to false and the second one to true, I'm going to look for everything in my current view. And so I think it's important to know how to do that. If both of those are false, it's actually going to do the entire project. It's going to find everything in the entire project before it runs your filter. Next is a category to filter. Right now it's set to walls. And what I'll do is after I do the walls, I'll show you how easy it is to change it to doors or to electrical equipment or whatever else you want to type it. It'll auto-complete, so you don't have to memorize what they're called. Then I have two options here. Do I want to export the element name? And do I want to export the parameter value? And which value do I want to export? And you can just type in the name of the parameter. And then whether that parameter is going to be an instance, a type, or either. And so these few options, I hope you understand that there's actually a lot of power that can come from just these few options. Now these options are all hard-coded. And eventually what you'd want to do is you'd want to actually put these into a form where you can actually select things, maybe it's radio buttons, drop-down lists, or whatever else, to be able to give users a better experience at actually making these selections. So once those are selected, you've got all the code that's going to run those filters. And I'll step through that in a minute. First, I've got the use selection. It's going to do the walls. Actually, if I'm doing the selection, this is true. It's not going to filter by walls. Let me show you what this does. So let's select a few things. According to the comments, it's going to export the name of the element. It's also going to export its mark value. Most of these don't have mark values. In fact, let me just set one of these. Let's set this wall. Its mark value is that. Select a couple walls. Select a couple doors. Oops, wrong tab. And let's run. And my super sexy form here. Click the button, it says it's done. And so what it's done is it's given me the name, which is in this case, it's the type name, and then whatever was stored in that mark value. So I'm going to step through this one time, show you how it works, and then we're going to continue on with the presentation. All right, so I'm telling it that I want to stop here. Let's go ahead and this time, it's going to filter for all walls. In fact, let's change it to filter for all doors. Let's show that real quick. So in here, I'm just going to hit dot, and I'm going to type in doors. And in Revit, in the API, it's called OST doors. So let's go ahead and do that. So now I'm just filtering by doors. I'm going to set this one to false. Selected items only, current view, whatever. And let's go ahead and build this. And then let's step through it to understand what it's doing. So build finish, got some warnings, that's okay. Ready, set, let's do step in 2. Step in 2 is going to take me to the first line of code, and it's essentially going to stop there. And it highlights in yellow. I'm just going to hit F5 to continue running until I've told it to stop. When I hit my button, this is a stop point. Now you can create stop points by going to the debug, and you can do toggle breakpoint. The interesting thing is that it's F7 is the shortcut key. That shortcut key, for some reason, changes whether you're in Visual Studio, whether you're in the old versions of C#. So go to the debug menu to figure out which button that you should be pressing if you want to toggle these on and off. So down here, as I mentioned before, there's the locals window. This local variables. shows you a list of all of the parameters. You can see down here, if you can read that, export element names is set to true, export parameter value is set to true, and as these things are changing, it'll actually update. And I'm going to, let me look what the next line, step into is F11. So let me go ahead and just step through this real quick. So it says it wasn't set to true. If it's current view only, there's a lot of if statements. It's not, so it's going to add collectors. It's going to add things from my document. This other element collector is a standard way to do filtering that's very well documented in the SDK. I'm just creating a list of all the elements in the project. Then I've got a couple filters that I'm going to combine. I've got a category filter, and that category to filter is going to reference in Visual Studio. If I hover over this, it tells me that it's set to OST doors. So let me go ahead and continue stepping. The inverted filter, if you put a true, comma true, on any one of these filters, it's going to invert it. Now it's not looking at if it matches the filter, it's for anything that doesn't match the filter. And I only want the instances, I don't want the type properties, and it's different than the type parameters, but I don't want the type definitions. I just want the instances that are in my project. And then I can combine these using a filter, and then I create a final filtered list that matches all of those filtered sets. Make a few more things if it's selected items only. I insert it to my elements to be modified, etc., etc. Already getting a little bit bored here, so let's skip down here. I'm going to hit F5. And here, what I want you to see is that when I'm creating which strings I want to export, this is where I'm actually getting the data. Is I have a current element, and when you hit your element, the element is predefined by Revit of what an element is. Current element was just a name that I made up, and I said it's a type of element. But as long as it's a type of element, when I hit dot after it, it'll give me a list of all the properties that are available for it. And in Revit, some of the things are properties, and some of the things are parameters. And so if it's a property, you just hit dot, and it'll have dot name, it might have dot location, it might have dot size, dot length, depending on what type of element it is. A lot of those properties are stored right in the element. If it's a parameter, it's actually stored in a list of parameters. So you actually have to return the parameters and then look through that list to get the parameter that you want. And so those are the two functions here. If it's a property, I'm using a dot name. If it's a parameter, I'm actually calling a function called get parameter value by name. Let me scroll down to show you where that jumps to. That jumps to this function here. Notice how it's relatively short, and almost all of this code is actually just it's declaring variables and determining what I'm going to do. As we're going to see in the next section, when we get to some of the key lines of code, you'll see highlighted how few lines of code are actually lifting and doing the heavy lifting and actually doing your work. And so in this case, if it's an instance parameter, I return the instance parameters. If it's the type parameters, we don't have time to go through every line of code here. That's why I'm giving you all this code so you can kind of step through it. You can work on it on your own time. And then that one's pretty simple, and it references this code down here below. And I'm just going to start scrolling, and you'll notice how long all this code right here, this actually is all just from converting units. It's just converting the units from whatever the API is storing, whether it's feet to meters to inches, Fahrenheit, Celsius. There are a lot of units that are actually used by the API that won't match your project units. So all this code that's down here is just a whole lot of conversion factors. You can get that online. I'm pretty sure it's in the SDK. None of this I had to type in. It's just, and I'm giving all that code to you. It's not my code. It's just I got it from online. It's all it is converting. So the code that I showed you, those two short snippets, those are the code that's actually doing the work. And then it's just calling a conversion if it happens to be numeric. If it's numeric, it's often going to be converted to between the project units and the API units. And that's important so that when you set the values back, you're setting it to the correct units that the user is expecting. So that's as far as I wanted to get with the live demo. And if you have questions later, we can do that, but there's still a lot of good stuff. So let's go back to the presentation. All right, so this next section, we're going to see some source code. And it's color-coded. Notice on the bottom right, there's a color code key that tells you that the red lines are the ones we're going to be talking about. All that purple stuff is really just declaring variables and stuff that it's useful to know, but the point of these slides is to understand that these are the key lines of code that maybe took you a week to figure out that one line in code that was going to do exactly what you wanted. So there's a few lessons learned in here. Notice also all of this is in VB.net. You can, as we said before, you can convert it to whatever you want, but just be aware this is VB.net code, so if you're pasting it into another language, make sure to convert it. So linked documents. Originally, I did all of my code just doing stuff in my current document because that's what I knew, and then people would ask, can you get the information from the linked document? Can you do this? And I'm like, I'm sure it's possible, but I'm sure it's probably pretty complicated too, so I'll worry about that later. Turns out it's really, really simple. And so in the upper right, I've just got the screenshot from that program. This can be very useful this program will find the windows in the linked document, it'll find its location, its size, and then you can create elements in the current document by ray tracing to the closest wall and creating something of the same size. Just one of the many examples of when it's very useful to get information from the linked document. So the first line of code here is there's a built-in command that's the link. The link collector is just a standard filter, it's just a standard collector of elements, but it's just a category filter. All I'm doing is I'm just saying, hey, give me all the Revit links. Now what this does, it gives me all of the information about the Revit links, but it actually doesn't give me the documents that I want to have the elements from. I want to get the information from. And so that first line of code is just to get the information about all of the links of my current document. Now the second section of red, this one, there's actually the myapp.application. The myapp is a name that I made up, but it is of type application. So as soon as I say it's application.documents, it returns me all of the documents that are in memory. This is everything that's opened. These are all your open documents, but it's also all of the documents that are linked to those open documents. And so if you only have one project open, essentially everything that's in there is going to be a linked document. So you may not have to do that first part, and you may not also have to say, the second part is just an if statement. I'm just saying if the link happens to exist in my list of linked documents for my current document, all that's doing is it's saying that if I've got multiple documents open, I don't want to treat this family or this other document as a link to my current document. And so it's just some code to match up the linked information to the list of documents that's in my current document. And then I just insert that, and then we'll see on the next slide how we can use that, how easy it is to use the linked document in our code. And so ray trace, and this is not to be confused with ray trace rendering. This is also called ray casting. Essentially, you've got this center point, throw this imaginary ray in a direction, and it's going to tell you all the things that it hits. It's not just going to stop at the first thing it hits, because it might actually hit a chair first, then it hits the desk, and then it hits the wall. You might not be concerned about all the little stuff. You might want to then filter just for the walls. And so that's what I've done here is you first have to set up a start point. So that start point could be the center of a space. It could be the location of an element you found in a linked model. It's an XYZ coordinate. So I put in the comment there, you're going to have to decide what that starting point is. Then going down to the first red line of code, the find references with context by direction, that's a built-in command that's going to, you give it those inputs. If we look here at the inputs, my original location, that's my starting point. My ray direction, that's a vector direction, could be left, right, could be diagonal, could be in any direction. And then I do have to know a 3D view that the elements are going to exist in. And so you're going to have to determine, there's different ways to determine whether you want the default 3D view, you want to create a 3D view. There's different things you can do for that. But the interesting thing is the very first part, this my link document, that could just as easily be my doc, the current document. And that's the only difference between finding elements in the linked model, finding parameters in the linked model, or doing it in my own document, is instead of passing it my current document, all I have to do is switch it for a document that's the linked document, because they're all essentially documents to the Revit API. In the link document, there are some very minor limitations of information you can and cannot use, but for the most part, all the information's there, the elements are there, you can get the element IDs, the parameter values, do the ray tracing, all that stuff in that link document. And that's what I want to stress is how easy it is. It's essentially the same whether you're doing it in my document or if you want to include the links in the searches as well, it's just as easy. There is a new, starting in 2013, there's a reference intersector class that was meant to simplify some of that. There's a question here. So the question is, in this case, am I using the link document because I want to hit a wall? And yes, I'm an electrical engineer, and a lot of times we have an architectural model that's linked into ours. So if I actually do a ray trace in mine and say find walls, it's just going to keep going, and it's not going to find anything. So in the tools, I have a drop-down list that'll show all the documents in memory. You can say, which one do you want to use for ray tracing geometry? And you select the architectural one. And then that one will return the walls that you're interested in. So going all the way down to the bottom, you're going to get back a list of references. These references are references to elements. And the most important thing that I'm usually concerned with is what's called the global point. And that's where the ray actually intersects or hits that element. And so that's the point that I'm really interested in, because it might be where I want to host something. It might be where I want to use it for doing some other command. But just be aware that it's stored under global point. That's the XYZ coordinate of that intersection. And going back to when I first started Revit, I was amazed that there's this 3D environment, but not only is it 3D, but you understand that things are walls and doors. And so in my daydreams, I was thinking, wow, I can analyze this space, and I could start to decide where things are going to be spaced, at what intervals they're going to be spaced. I could click a button, go to sleep, collect paycheck. That was my dream. So I set out to accomplish that dream, and it hasn't come to fruition yet. I haven't gotten any more naps, but I have learned a few things along the way. So the first problem that I was trying to solve is I've got this space. I want to figure out maybe the spacing around the perimeter. And so I thought, how am I going to accomplish this? Maybe I'll start a ray at the center of the space, and I'll send out rays like in spokes. And I can use a little bit of trigonometry and figure out what angle I need to shoot out each ray to make sure that the spacing is consistent. And then I was thinking about that, and I go, what if it's like an L-shaped or a C-shaped room? Some of this stuff is going to kind of fall apart. Well, it turns out all that problem was already solved for me in that spaces and rooms already have a built-in function called get boundary segments. It already tells me where all the border lines of the entire space is. So all I had to do is what I ended up doing is just choosing the center of the space, and I just chose a direction. I just said shoot down, find the starting point on that, basically that list of the boundary, and just use that as your starting point. Just use that as your starting point, and then start counting along that vector direction every 6 feet or 12 feet or whatever the user input. And so that's how that was solved. But it was interesting to think about. The other problem that I came across was that when you want to host an element, if you're hosting an element inside your own model, if it's hosting to a wall that's in your model, to a piece of equipment that's in your model, it's really easy. It's just one line of code. It's just a built-in function, and we're looking at the red line of code here. And it's just, I want to create a new family instance. I give it a temp reference. That's just the reference that was returned from my ray casting. So I already have that reference. The location, that's maybe where that intersection, that global point. My reference direction, I need to know, how it's being hosted. Usually that's perpendicular to the surface. And then which family that I'm going to create there. So those are the inputs. So, and there are different iterations of that where there are different inputs that you can put in there, whether you're hosting to a face or whatever else. But it turns out if it's a linked model, sometimes it worked and sometimes it didn't. Sometimes I would host elements to the linked model and it would be in the right place, and other times, depending on which direction I was shooting the ray or whatever else, it would show up on the floor. It might show up 2 rooms across the way. So to to fix that, what I ended up doing is just creating reference plane. I found the location of the wall, and I knew the geometry of the wall. You have access to all that stuff, and I just said, okay, just create a reference plane there, host it to the reference plane, and then delete the reference plane. Now, one thing that does, a side effect of that, is that when you delete whatever it's hosted to, if you click on the element, it'll say it's not associated. So the element essentially is not associated. It's floating there, although it's in the exact right position. So it's still going to work with your systems. It's still going to work. It's going to be in the right location. Most of the time, it's not really going to matter. If the architect moves the wall, it's not going to move that with it. But just create another button for that. So I have move closest wall button. It says, hey, send a ray trace in the directions, find your closest wall, and snap to that location. So problem solved, right? So probably my favorite part about the Revit API is actually getting into the data and manipulating the data, the model, watching things grow and shrink and whatever else while you're changing those parameters. And so many years ago, I got a little bit frustrated with the way that Revit was setting parameters. I would select multiple things, and if they were different family types or if they were different categories, the same variable or the same parameter name would disappear, and I couldn't set it the same variable name for multiple categories or multiple families at the same time, even though they were the exact same name and everything else, but because they happened to be family parameters instead of shared parameters, and I said, I don't really care which one they are, I just want to set them, and I don't want to have to select them individually. There's the filtering in Revit, where you've got the filtering and you say, you've got the filter options, it's just by category. Well, what if I don't want just all light fixtures, I want this specific light fixture that is of this specific type. Or maybe I want all lighting fixtures that are 2 feet wide. Well, all these filterings that are not available within Revit in the filter command unless you go through and start creating a whole bunch of custom schedules and you're changing all the filtering and the things. So I set out to change that, and that was a lot of the source code that we looked at in the macro was started the beginnings of that was, okay, how do I start filtering things? How do I start setting and getting the parameter data? And that was sort of the birth of the parameter transformer, which also does all that stuff, and it sends it to Excel, gets it back from Excel. You can export to Excel, you can actually get the linked element parameters, send it to somebody else. They can fill it in and send it back to you. You can import it in, that kind of stuff. But the point that I want this slide to make is that a lot of that stuff that's happening is all based on some very simple lines of code, some simple building blocks that you then wrap those around in loops and in if statements and whatever else to make it do what you want it to do. But it all comes down to some very basic lines of code. So here, getting and setting parameter values. To set a parameter, once you've found your parameters, in which we've done in the macro, you've got the code to do that, and there's also stuff in the software development kit. It's just a .set command. You just .set and you give it a value. It's as simple as that. And then reading is essentially the same thing. As you've got your current parameter value, and you just set it to this is where are we at? This is the setting, this is the reading, and you can just read the parameter, and then you say what type, whether it's a string, a number, or whatever else, you can return that into your variable. And I have in green here to remember the convert from API and convert to API. That's that boilerplate code that I showed you there that you can download that just is making sure that the units match with your project units. And then element filters. This is probably one of the most well-documented subjects in the API. It's all over the SDK. It's all over online. But what I kind of had a hard time finding was an example of how to do compound filters. I want to do filter for this or this, and then I want to AND it with this, and then I want to keep going, and I want to add filter upon filter upon filter and build all these custom filters. And so I wanted to give you that example. So here, this is how you start any standard filters. I have this element collector. I'm going to collect all of my elements that match these filter parameters, the rules. And so I'm going to first do 2 category filters. One, I'm going to do a category filter for electrical circuits. Then I'm going to do a category filter for electrical internal circuits. You don't need to understand the difference. It's just whether it's a circuit or a spare or a space in the panel schedule. You can forget all that, but the point is that I'm doing 2 different categories, but I want the things that match either one of those. I want both the electrical circuits and the electrical internal circuits, and so I use an OR filter. But I'm not done. I want to keep going. So I also, not only do I want both of those categories, but I also want only the elements that are instances. I don't want to get all of the type information, the type definitions. And so then I have this class filter, and then I combine again, and I say I'm doing an AND filter, where I'm going to do all of my elements that I've got, but also my inverted filter, which is only getting the instances.
So this will also work for like if I have a system, each individual, like we can also do a system.
So the question is, can you use this for systems as well? Systems and zones, same exact things. You wouldn't use electrical circuits, you would just change it to the HVAC zones or whatever else. That's exactly the same process that you do. And the point is that this new combined filter, this pre-combined filter, basically you could continue this pattern over and over as many times as you want, where you could create a new filter and then do another combined filter where I'm either ANDing them or ORing them together. And you can continue that pattern. You can do it manually, you can put it into a loop, recursion, or whatever you want to get exactly what you want from your model. And then the important thing is that you don't want to pass all of those rules to your element collector until the very end. Basically, you want to combine all your rules together first, and then in one pass, I've got my collector that I created, and then this is a built-in function, where passes, and then I just pass it all those rules, the combined rules. These are the rules, and then when it gets through all those rules, it's going to give me a list of all the elements in my final element result. Sheet and view creation. So this is a tedious task that people are creating hundreds and hundreds of views, hundreds and hundreds of sheets. And so my original thought, well, let's just take that all from Excel and just dump it into your project. That way you can just type it all up in Excel, and then you can create all of the views and sheets at once. What it sort of evolved into was be able to create templates, where you have a template for a specific client, or you have templates for specific, maybe it's healthcare, maybe it's multifamily, maybe it's fabrication plant. You might have different views, and so you can create a template of views to create per level, views to create per project, same thing with sheets per level and sheets per project. And so you don't have to have any of that stuff pre-populated in your model. You can create a template, use the right template for your project type that you're starting, and just say, ready, set, go. And then it can also put those views onto your sheets automatically if you'd like. Or using the parameter transformer, you could put those existing views onto existing sheets if you wanted to create dependent views or whatever else. But again, the point here is that there's really only one line of code to create a sheet, and there's only one line of code to create a view. The interesting thing here is that you actually create the sheet first and then set its name and its sheet number. The inputs for creating a sheet is just the title block. And so you have to just iterate through your title blocks. What I've done, if you notice in this application, is I just say, I have a drop-down box where I just said, list all the title blocks in my project and throw it to the data source of that drop-down box. And so that combo box there will have a list so they can just choose whichever one. And then I just say, if the name matches the combo box, that's the one that you want to input in when you're creating the sheet. So you do just have to pass it a title block. After that, you can set its name, you can set its number, and then you can go beyond that. You can start setting parameter values for it.
So the drop-down box, you have that action, look for the title block list. Where is that written into the box in itself?
The question is this, when it's looking for the title block to match, where is that code written? Is it written into the button? Basically, there's two parts of that code. On the form load, I say when this form loads up, I want you to look through, list all title blocks in the project, and then list their names in this list box, or in this combo box. And so they're listed there right when the form opens. Then on the button click, I say, when I click this button, I iterate through all of the title blocks in the project, and I say, if the title block.name or the name matches the selected item in my list box there, then this is the title block to use. And so it's just a matching. It's just if it equals this, but I have to iterate through them again. Does that make sense?
How is this different than the create new sheet button? Are you doing multiple sheets at one time?
I'm doing hundreds of sheets at a time. Not only am I doing hundreds of sheets, but it's naming them exactly how I want. I can get those names are actually pre-populated for my template. I can say for each level in my project, I want a floor plan, I want a ceiling plan, I want an exiting plan, I want a piping plan, I want an electrical plan. I can give it a list, and then when I hit the generate, I go to the generate tab, it'll actually have level 1 ceiling plan, level 1 piping plan, level 2 ceiling plan, piping plan. It actually lists all of the levels. So I actually set a short list of like say 5, and then I say, okay, generate it for all levels, and it shows me all the levels. And I can delete the ones I want, I can rename them. I can also then say edit in Excel, and then I can type them all in Excel. So I've got a list, it could be 100, 200 sheets, and I hit create, and it actually create them all with the correct numbers, with the correct names, all that stuff at once. Question?
Can I assign the view template, the scope box, positioning of the view on the sheet, all that?
Can you assign a view template? Can you assign a scope box? Can you assign position on the sheet? The answer is yes, yes, and yes. So I'm going to, the next slide here is view templates. Now, so let's talk about view templates, but to answer your other question, the assigning the location on the sheet and the scope box, this program that I'm showing actually doesn't do that, but the parameter transformer does. So the creation will create it with the default whatever, and then I can go through and say in the parameter transformer, give me all sheets, find all sheets whose name contains sector A, and set their scope box to sector A scope box or whatever. And I can do that for the entire project. And I can do that either using the interface, or I can do it in Excel too, where I can list them by sector, and then I can just paste down sector A scope box, sector B scope box, whatever else. So half of your answer is in this program, and the other half is actually in the parameter transformer. So applying a view template. So the interesting thing, so here's how you do it. I'm not going to go through all the code here. We've got about 10 minutes left. What I want you to know is that starting in 2013, you can either lock a view template or you can just apply the settings. And there's a difference in that when it's locked, when you change that view template, it's going to change everything it's applied to. And it's just a simple built-in function where you set the view template ID, and that will lock it to it. If you set apply view template parameters, those are both built-in functions. Whichever one you use is what it's going to do. It's going to either lock it, or it's just going to apply it this once, but then it's still free. You have access to edit it. And then family parameters. So this was a tool where maybe we're downloading manufacturer's content, and they have a lot of their built-in parameters, but none of it works on our schedules. And so we have our standard shared parameters that we need to have for all of our air handling units, or all of our doors, or all of our whatever. Well, what you can do is you can create a template of what parameters it takes to be compatible with your systems, with your schedules, and you just save it as a template called AHU or compressor or whatever else you want it to do. So essentially, when you get new content, whether you're creating it, whether you're downloading it, you just click the name of the schedule you want it to be compatible with and hit apply parameters. You can do that for a family. You can also add parameters to a project. You can also transfer parameters from one project to another. You can merge them with a shared parameter file. You can transfer them from one family to another. You can also create maps where the manufacturer did a good job of linking their length and their width to actual geometry and dimensions, and I don't want to delete those and add my own. I actually want to map. So wherever they have length, I want you to use my special length. And then it will map it, but keep all of the parameters, the formulas, the dimensions, all that stuff intact. So again, notice how there's only one line that's red on the screen, and that is adding a parameter. Now this is to add a family parameter. In a project, you can add a project parameters, slightly different, but just familymanager.addParameter. It's going to want to know what your shared parameter definition is. So that's coming from a shared parameter file. You can either create one on the fly, or you can use an existing one, which group, and whether it's an instance or type. And that's documented in the software development kit, but this is how you do it. This is how you, for each group in my shared parameter file, and then for each shared parameter definition, that's how you actually get these variables, and you can then use them in your code. Going through here, this is the last code, and then we're going to go through some other stuff really quick. Excel. Excel is very useful in engineering, architecture, construction. People use Excel a lot, and so it is very important to know how to do. Now, Excel is not a database. It's not as good as Access, it's not as good as SQL, it's not as good as the other stuff, but it's so useful and it's so prevalent that it's very important to know how to connect to it. Essentially, as I mentioned before, very important to load in the reference. That's the first step, is you have to say, go to add reference, add my Excel reference, so that is going to give you access to know what an Excel file is, what a worksheet is. So now as you type in as a new worksheet, it already knows what that is, and it already knows when you hit dot after that, hey, these are the things I'm allowed to do with a worksheet. And so the most fundamental things that you want to do when you're accessing a database or Excel is you want to read and you want to write. Those are the two basic things. So that's what I chose to highlight here. Reading is just saying, hey, this is my worksheet that I've defined by my variables, and this is just a file that contains wherever it is, and you can set that any way you want. Just have my worksheet dot range, and you type in the range and you return the value. Same thing if I want to set the value of the range, I just say the range dot value equals the new value. Simple as that. Now, this is the basic how to read, how to write, but I also want you to know that you're not limited to just these. You can do it. You can access these same things by column number, by row number. You can access these things by named range. You have, once you load in that Excel reference, you have access to a whole bunch of additional features and functions. All right, one last video, and this is actually from my Autodesk University 2010 class. What I want you to get out of this video is how we can actually, once we've got all this data, so we've talked about getting the data, getting this stuff in Revit, how we can actually interface it with our existing workflows, how we can actually use this data and maybe use it with external calculations and such. So with that, let's...
In producing construction...
Hold on. Oh.
So it also work with lookup tables, like if I refer to a lookup table, because basically a lookup table is...
So can you refer it to a lookup table? You can refer anything to a lookup table that you create, whether it's Excel, Access, or whatever else. Now, what you can't do is there's family lookup tables and some other stuff. You have to follow their rules when you're doing that. But if you wanted to create your own lookup tables and create your own functions, yeah, you can do all that. All right, let's get to the video.
In producing construction documents from Revit, you may find yourself desiring to incorporate data from other sources, perform custom calculations using Revit model data, or even automate documentation procedures. We can look at one electrical example that may not be directly related to your field, but you'll be able to see a real-life application demonstrating communication techniques that can be applied to any number of solutions. From the Revit Add-ins tab, you can export the electrical system to an Access database, which can then be used to conveniently manipulate the model with greater flexibility and control than allowed by Revit. In a custom and convenient interface, you can view and modify device parameters, search for specific devices, or modify electrical panel schedules with custom demand factors, calculations, and formatting. These custom panel schedules can be exported to CAD and linked into the Revit model. Short circuit and voltage drop calculations can be automatically computed in the database, or you can choose to export Revit system distances to SKM Power Tools for more advanced system modeling and analysis. Once complete, the results of the SKM analysis can be pulled back into the database. The combined updated data, including accurate equipment ratings, can then be sent back into the Revit model for all the equipment. Whether the electrical system was created in Revit, SKM, or in the database itself, a one-line riser diagram can be generated using AutoCAD. Device building level information, calculations, notes, and other items can be automatically included in the diagram. In the database, you can also receive automatic notifications of mechanical changes that affect electrical, and view the history of these design changes. Mechanical equipment disconnects can be sized automatically, and CAD schedules can be generated that combine.
I'm going to cut that short because we are running short on time. Just some few final notes. Most of what we've talked about today have to do with this first point here, functionality. And this is getting access to the data, being able to set it, manipulate it, making it actually do what you want. Now there's three other sections that, these are just sections that I made up, but they're things to consider when you are thinking about creating an application. The second is universality. And so when you're thinking about, you first hard code to make sure that it can be done, but then you have to think about what other users are going to be using it for. You then want to add in options. You want to add in options for categories. Instead of just filtering out walls and just renumbering the mark values for walls or doors, well, maybe somebody else wants to renumber their room numbers or whatever else. So you add these things to make it universal. So the interesting thing about the parameter transformer is I really kept that as a core functionality, is make it as universal as I could. And the funny thing is that people are actually showing me how to use the software. And they're saying, hey, did you know that you can actually use this to purge out your extra filters in the project or whatever? I'm like, well, I never even considered using that as an option. They're like showing me new ways to use the tools that I developed, and I'm like, wow, I mean, you guys are teaching me, that's pretty cool. The aesthetics, it's more than just making it look cool, making it look nice, but it's also making it user-friendly, making it in a way that makes sense. Some people might disagree that I put this into my applications, that there's a certain things that make sense to me, and then I've realized later that, oh, I guess if you weren't an engineer, that may not make sense to you, kind of thing. So then I have to kind of rethink those aesthetics. And then the last one that I don't want to say it surprised me, but it kind of surprised me of how much effort you have to put into this is the deployment, the distribution, and the licensing. And this only applies if you're planning on giving it to other people. But it turns out that if people said, hey, I want to pay for your software, and I'm like, all right, sure, just send me some money, right? You know, you have to start thinking about how you're going to get it to them, how you're going to decide whether they've been licensed or not, do they have permission to the software, and then you get all these different networks, and they have different network permissions, and they have different IT administrators, and they've got different versions of Windows, different versions of Excel, and there's so many things that can go wrong, and then you end up having to tweak all these things that, hey, it worked perfectly for me, but it doesn't work perfectly for everybody on every machine. And so then you start spending a lot of time actually making this a little bit more acceptable to deployment servers, to all this other stuff that you just didn't think about when you were concerned just on the functionality. So we're going to skip the ideas for future development, just some ideas that you can look over. But with that, I just want to say thank you. Thank you so much for attending. And hopefully you guys can feel free to email me, let me know projects you're working on, if you have questions. I'm really interested in hearing feedback as to whether this really helped you get started and start making your own ideas and using them on your projects. Thank you.